to walk through a setup of SuperSlicerMx on the Windows environment. And SuperSlicerMx is a version of SuperSlicer, which is a version of Prusa Slicer that I've been working on to support mixing hot-end 3D printers because there's a dearth of them out there. Not very many systems actually support them internally. So this is a beta level product or a beta level implementation. Still got a lot of work to do on it, but if you'd like to get started, it's working, it's fairly stable. There's a few things that are a little quirky, but I'll try to tell you about those as we go along. So the first thing we need to do is go and get it. And it's sitting up in GitHub. So we'll go to the browser here and we're going to go to GitHub to retrieve it. Go to Nanoplane, which is me. And we're going to go to SuperSlicerMx. You see I've been there before. And here's where the code is for SuperSlicer. So all the source code's here. There's a place for you to put publish issues if you have a problem with it. You probably have to have an account on GitHub, but you can do that and set up post issues. And we can go to retrieve the current builds. There's nothing that's released yet because it's still in a beta level. So we'll click the releases tag over here. Just basically click on where it says releases. And we're at beta 7, so we'll click on that. And what we're going to want to do is retrieve the documentation, the Windows directory with everything in it, and the bundle, config bundle.ini. So let's see, we'll retrieve the documentation file. We'll start the download of the zip. And we're going to go and get the bundle. Now one thing is the bundle, it decides that it doesn't like that, so it can harm you. So you have to go up here and force it to accept it by clicking more actions and keep. It'll take another half minute or so to download. I have a slow internet. Okay, so it's downloaded, and what we want to do is go to our downloads folder. Downloads, and here they all are. So we're going to open up the zip file here, and this folder here contains all of SuperSlicerMx. There's no installer, so you have to perform the basic installation functions yourself. You can drag this to your desktop if you want. If you don't want to actually install it in your applications or your programs folder, but I'm going to put it right in my programs. So I'm going to go over here and going to get my File Explorer, go to my drive, go to Program Files, and I'm going to take SuperSlicerMx here and drag it over to my program files. Don't drop it on one of the existing folders because it'll get lost. I have to provide administrative permission because I'm modifying my programs. Take a couple of minutes to get everything done. A lot of files. Okay, so now it's been moved over. We'll close our, back this out here, and now we won't do that yet. So go to the program files, we'll find the folder for SuperSlicerMx, open that, and we want to take SuperSlicerMx here, and we want to right click on it. And then what we want to do is do one of two things. You can pin it to the taskbar, which I'll do. And the second thing I want to do is I want to create a shortcut for the desktop. So I'll create a shortcut here. I want to put the shortcut on the desktop itself. Yes. Okay, so now we have two places where we can launch SuperSlicer. So let's close this program files SuperSlicerMx folder window, and we're all ready to go. So let's start it up and see what happens. I'm going to start it here from the taskbar. So it starts up, and since it's a brand new environment, it wants to have us configure a machine. Don't have the machine in here yet, so but I do have the bundle ini file to import everything I need. So we'll cancel this here. We'll go to File, we'll import, and we'll import config bundle. And then we're going to go to our downloads and import the SuperSlicerMx config bundle. And that goes in and sets everything up. It's got 25 presets for all different kinds of things, and we can go and take a look at everything the way it's set up. So let's give it a start. We'll go here to our printer settings, and we'll show you what it looks like. Yeah, first thing we got to do is we want to take a look at we don't want to be under simple mode over here. We want to be on export or expert, so we can see everything. Click the export and everything pops up. So here's the basics behind setting things up as a mixing hot end. So we can set any number of extruders we want. Each one of these extruders will represent a color or a mixture, a mix ratio, or each one can represent a single color. It can represent a gradient, or it can represent a set of layers. But I've got 9 of them set up here, which will allow me 9 of these settings to use when I'm coloring an object or multiple objects on the screen. So I tell it the number of extruders I want. It's single extruder multi-material. We do that so it actually creates a wipe tower and has a setup for multi-material. And we don't have any milling cutters. We don't want to worry about that. You'll see the G-code flavor here is RepRap firmware, and we need that because that's what the crane runs on. We use relative e-distances. We don't really have any other changes that we want to do on this particular page. The bed shape and size here has already been set up for the crane, 230 by 230, and so that's all we've got so far. Okay, so custom G-code. What we do is we have the ability here in the custom G-code. There's a couple of important things. If you have a BL touch, you can do auto bed leveling. It moves it to the purge position. I'm taking advantage of bringing things up to temperature here. I'm setting T0. You got to set T0 because it could be on any previous extruder before, so make sure that you got the right one set. And I'm calling the print start G. So M98 is a call to a subfunction. P is the parameter that you're setting, and the name represents the name, and print start G is the name. You'll find that in the systems files when you look on DWC. And then once we're finished with that, we'll reset it to whatever the initial extruder is. Because once you've set up a color scheme for your objects, the application decides what the first extruder should be, and it expects that to be set up when it leaves the start G code. So here's what the extruder, here's where the magic happens. When we set up an extruder as a mixing extruder, there's a couple of things we got to do. One is we can give it a name. You can give it this name. This name will show up as the tool name on DWC to let you map and understand what colors or what tool is actually being used to print. Here's the section for mixing. We set a flag that says it's a single extruder mixer. We decide how many filaments are in the mix. This means it's built to support more or fewer or more filaments in a mixture. So, for example, if you have a different mixing hot end that only supports 3, you could set that to 3. This section here is the mix ratios. And I only want 4. It ignores anything after the 4th. And this mix ratio can either be set up as a gradient. You can click this flag and include multiple values in here. Height is absolute, and gradient are things, and this height field here, we'll talk about those when we do gradients, when I show you gradients. You can manage the tool life cycle. Usually what I do is I don't manage the tool life cycle for extruder number 1 because I want to make sure that I don't modify sort of the base level configuration of the machine. So I leave this blank for tool 1. Tool 2, on the other hand, we'll go over here. Tool 2 here is set up as a gradient, and I manage the tool life cycle, and this string is what is used to configure and create the new tool. It's the part of the creation function, which is M567. No, sorry, M563. That creates the new tool. You shouldn't have to modify this at all. It's the same for every single extruder, and it works for the crane. So here's how gradients work. This one is set up with a gradient here, but I haven't clicked to determine whether it's a gradient or not. So if gradient is set, it's a gradient. If it's not set, then these are layers. And these are color layers starting from the top going down. So the first color layer has a mixture ratio of 0, 1, 0, 0, so it's all magenta. The second one has a mixed ratio of 0.7, 0.1, 0.1, 0.1, and so basically it's all cyan, except for 10% of everything else. The last one here is 0.25 for everything, so it's blah. It's basically gray or dark gray. This field over here is to set up the height for each one of those layers. So the height isn't at an absolute value, so these are basically the height of that particular layer relative to itself. So you see the bottom layer here is 25 millimeters high, the second layer above it is 30 millimeters high, and the top layer takes up whatever's left. If you leave any of these values blank, it basically tells the computer to figure out how high that layer should be based on what's left and how many blanks you have. If I had set this height as absolute here, then these are actual heights above the base where that layer starts. So if I click this, for example, the first layer here would start 20 millimeters off the ground and would be that value from 0 to 20 millimeters. The next layer here would start 30 millimeters off the ground. So the first one would be not only from 0 to 20, but from 20 to 30. And the last one here would be distributed across whatever's left. Because this starts at 30 millimeters, let's say you had a 100 millimeter tall device, then this one here would split its height between these two, if that makes sense. So basically it would be 30 here plus 70 is 100. So the 70 millimeters is split between two of them, and this next one here, this leaving it blank would be the same as putting 65, because each section would be 35 millimeters tall. But we'll leave that out because layers are easier just by height. And we're doing gradients anyway. The rest of the stuff is normal things for normal stuff for SuperSlicer or for a Prusa slicer. You can change those values to be whatever you want. These are values I've set up for some of my tests, but they're by no means 100% accurate. Next thing is single extruder multi-material setup. This is where we set up for parameters, and you want basically, if you want to use advanced wiping volume, basically it lets the system calculate what these need to be. You can set these volumes to be whatever you like. 10 is awfully low. For most people, you'd probably want this to be about 40 or 50. So we'll change that for now. Once you've changed everything you want, we can do a save by clicking that, and it updates it for multicolor. Let's go back to general here let's go to the next thing here. Filament settings. There's no changes to filament settings over the basic stuff, so you set this for whatever you want your filament to be. There's a multi-material setting. And most of these things you want to make sure they're all 0. There's a wipe tower parameters, so you can have the minimum purge on a wipe tower. Set the fan speeds, miscellaneous stuff like that. And that's about it for filaments. Print settings. So for print settings, the biggest things are, let's see, this is all very, very basic stuff. Standard SuperSlicer functionality. Set it to what you like. Set your slicing, your infill, skirts and brims, supports material speed. Oh, speed is something for the crane. You may want to limit it to 4 or 4.5 millimeters per cubic, or 4.5 millimeters cubed per second, cubic millimeters per second, because the crane can't print very fast. And the most important one here is multiple extruders. So down here, we can enable our wipe tower. So click that to enable the wipe tower. You can set the brim width. You can set the width of the wipe tower. 30 or 60 millimeters is what's usual. Rotation angle, bridging distance for inside the wipe tower. Basically, if you know Prusa slicer, it leaves blank spaces, and this is the maximum size of that blank space. So that's the important things for the wipe tower. Let's go to the bladder. We'll see our initial wipe tower here is created, but it's created on the basis of all the filaments that have been defined. And we don't necessarily want to use all those. So what I'm going to do is, let's go and let's try and actually color something. So I'm going to go and import an STL. I did the clownfish. One of the things SuperSlicer does is if you try to import multiple objects, it wants you to determine or tell it whether or not they are part of a single object. In our case, that's true. That means they're all aligned properly for you. You'll notice that they're all the parts here are represented on the right-hand side, and each one's automatically colored based on or is assigned a particular extruder based on the default list we got. So let's say, for example, let's go here to our printer settings, and we are going to go to our multicolor palette here, which I've set up already, and this has some specific colors that I want to use. Okay, so what I'm going to do here is the first part here, the body here. Well, we want this to be white. So I'll make that white. The second part here, which is the lines, red is a good color for that. The space in the middle, yellow, yeah, that's probably a good color. And the last one of the eyes, we want the eyes to be blue. So we're going to go here and select blue. Just ignore that. Do you want blue eyes? I think we want brown. Well, yeah, we'll do blue eyes. Now you notice these are all the basic colors, right? So we will go and slice. Now the system doesn't just shows whatever color you've set up for that particular extruder, and doesn't really go anywhere beyond that. So in this case, you'll see, I think it's chosen the default print settings for the application, printer settings, multi. See, I don't have advanced wiping volume. I'm going to turn on advanced wiping volume because I like it. I'm going to say nozzle volume is 40 millimeters, and so that'll be cool. Go back to the platter here, slice, and you see our little tower has been reduced in size significantly. Okay, so this is our clownfish. It's been sliced, it's been colored, white, yellow, red, and blue eyes. There's a waste tower or a wipe tower set up for it. We can export the G-code, or if you've set it up, you can send it directly to the printer. SuperSlicer and PrusaSlicer allow you to do that. Set an IP address for the printer. And we'll export that G-code here. I want to put it somewhere it's easy to find. We'll go get it here. Here it is, clownfish. Now let's go take a look at it. We'll go and edit it in the editor to see what it looks like. So I'm going to open it with the notepad. Okay, so generated by SuperSlicer. So we'll go down here, we'll see here's where the tools all get created. Create the yellow tool, sets the mix ratio, does all that. Sets the temperature for each one, goes through here, prints the startup code, and then continues on and starts printing. It sets the mix ratio after the startup code because it might have changed. So we want to make sure that we have exactly what we wanted. And it goes from there. Every time there's a tool change, it will run through and do the right thing. Basically, whenever there's a layer change or a tool change, it determines whether or not the mix ratio needs to be modified based on the current tool, and it does basically generates the wipe tower or creates wipe tower data for that. And that's about it. Actually, why don't we try this here? I'm going to go to my crane quad. just to give you an idea. I mean, it won't actually, I don't really want to actually print it, but I can drop it in there to show you what it looks like. So we'll take our clownfish file, we'll upload it and start it. So it uploads it to the printer. And what we're going to do is we'll pause the print here, because we don't want to actually print because there's nothing in there. But you'll see over here where the tools are, it only outputs the tools that are actually used for my printing, and it puts them in the order that they're defined for the printers, basically in numerical order, and plus the bed. You'll find that as it's printing, it will update the temperature here for the active tool. So as it changes active tool, it updates the temperature. I'm probably going to modify that to set all the temperatures at the same time to make it more consistent with how SuperSlicer does its own purging functionality. There's a bug in the code right now. If you try to have the SuperSlicer or SuperSlicer purge for you instead of calling the purge function, the purge macro. And that's about it. That's where we're at. I'm gonna reset this. Go away. So if you want to give it a whirl, give it a whirl. It's like I said, it's pretty effective. It's pretty stable. None of the basic functionality I've shown you has crashed at all. So enjoy.